This is a super quick video tutorial on how to name halogenoalkanes or haloalkanes or alkyl halides. Whatever you want to call them, that's just fine with me. So let's make a start. As the name suggests, a halogenoalkane is simply an alkane where one of the groups has been substituted for a halogen. In this case, X stands for the halogen, and it could be fluorine, chlorine, bromine or iodine. Of course, the hydrogens don't need to be hydrogens. We're not just talking about substituted methane here. So these could be methyl groups or any other alkyl group, or perhaps even a benzene ring. They're named as if they are substituted alkanes. So if we start with this molecule here, and I'm going to put an iodine on that carbon there. This would be 2-iodopentane. It's pentane because we have 5 carbons in the alkane, in the parent alkane. Iodo because the halogen here is an iodine. If it was chlorine, it'd be chloro, bromo, fluoro, and so on. And we give our halogen the lowest possible number, which means in this particular example, I am numbering in this direction. Okay, so it's 2-iodopentane, not 4-iodopentane. Give it the lowest possible number. Now, if we've got more than one halogen in our molecule, we are going to name them alphabetically, not numerically. So in this particular case, well, I want to give them the lowest possible numbers, so I would want to number from the left to the right. However, C becomes before F in the alphabet, so this would be 3 chloro, 2 fluoro, and there are 6 carbons, hexane. So alphabetically, not numerically, we've given the lowest possible numbers. And also, a couple of things I want to point out. We have dashes between numbers and letters in the name, but where I've got 2 words essentially, we run them together as if they're one. When I'm drawing this skeletally, the bond from the carbon to the halogen is slightly shorter than the carbon-carbon bonds. The same applies if I've got side groups as well as halogens in my molecule. I want to give them the lowest possible number, so again I am going to number from the left, so 1, 2, 3, 4, 5, 6. I've got a methyl group here. Okay, so CH3. But skeletally just a line. B becomes before M in the alphabet, so this would be 3 bromo, 2 methyl hexane. And finally, we can classify halogenoalkanes as either primary, secondary or tertiary, depending on how many alkyl groups are bonded to the carbon that's part of the carbon-halogen bond. So at primary alkane, we might have something like so. Essentially, however we draw it out, we have got one alkyl group bonded to the carbon that's part of the carbon-halogen bond. Another shorthand for primary, it's often seen as 1 with a little 0 or 1 with a little y. Secondary, we've got 2 alkyl groups. So, might have a methyl group there. Let's put in a halogen, another methyl group, and this would be a secondary haloalkane or halogenoalkane. And finally, tertiary, I'm sure you have guessed, we have got 3 alkyl groups, and obviously they don't have to be methyl, they could be anything. So that would be tertiary or 3 with a little y. Another point When we're drawing out the CH3, when it's kind of written backwards, we need to be clear that it's the carbon-to-carbon bond. So that's why I've written the CH3 kind of backwards there. All too often, we see this, which is just lazy, and there's no excuse for it. So when you're drawing them out, even simply like so, get into a habit of making sure that the bonds and the atoms are accurate. It's important to be able to recognise whether halogenoalkane is primary, secondary or tertiary because it has an effect on the way that they react, on the reaction mechanism. And interestingly, that is exactly what I'm going to go on to talk about in my next video. If this has been helpful, then please like and subscribe. It makes a huge difference to a small channel like us. And tell everybody about how fantastic crunch chemistry is. See you next time.